Many researchers are interested in studying data scientist workflow and usually employ interviews as their main research method to this end. DS Workflow is a framework that allows researchers to conduct simultaneous quantitative research alongside traditional qualitative research. The ability to use both qualitative methods, such as think aloud, alongside quantitative analysis, could allow researchers to add a new dimension to their study of how data scientists think and work. This, in turn, could lead to the development of innovative assistive tools for data scientists. DS Workflow is made up of three components: Workflow Collection, which engages in the systematic collection of data through snapshots and other forms of recording; Workflow Reconstruction, which engages in reconstructing the data scientist workflow in chronological order; and Workflow Extraction, which engages in the extraction of useful information from the reconstructed workflow. Workflow collection is carried out via a Jupyter notebook while the data scientists write Python code for completing a data science task, such as developing a machine learning model to predict something about a particular dataset. For example, suppose a data scientist would like to predict whether it will rain tomorrow based on today's weather. I begin by importing functions from the machine learning API that we developed on the top of scikit-learn and other libraries for our experiments. We recommend using this API in your studies in order to be able to focus on your participants' thinking process rather than their technical proficiency in the use of a particular Python library. I then write code which reads the dataset from a CSV file. I split the data to train and test. I perform some feature selection by choosing the features rain today, which is a Boolean feature that describes whether it rained today, mean temp, and average wind speed. I train a random forest model, and finally I evaluate my model by printing the accuracy. Okay, now I want to try to improve my model by removing the average wind speed feature, which I believe is not relevant to my model, and then I train and evaluate my model again. The second component reconstructs the entire workflow. As we have shown in our example, the data scientist can run the notebook cells in different orders and repeatedly, which is very common in typical data science and machine learning tasks. For example, the notebook we developed in our example was reconstructed to this notebook. Furthermore, the data collection component allows you, as the researcher, to also collect additional artifacts such as those associated with the think aloud methodology, where you ask the data scientists to think aloud while you record their screen and their spoken words. You can also add additional qualitative data, such as that obtained by using eye tracking equipment. All such observations can then be synchronized with the code workflow artifact. The last component is workflow extraction, which extracts relevant and useful information that helps you achieve your research goals. For example, one study in which we employed this workflow aimed to predict when data scientists would get stuck during the development of predictive models. Here, for example, is a graph that describes the number of models trained as a function of time in one of the experimental sessions that we conducted for our research using this workflow. Finally, we can synchronize the graph with the screen recording and the audio recordings collected via our Think Aloud methodology in order to see what the data scientist did during every minute of each experimental session. We are confident that our DS workflow framework will help researchers study data scientists using both quantitative and qualitative methodologies. We invite you to download our code at the link on the screen. Please come to our poster or contact us with any questions. Thank you.